This lecture is on the second half of Chapter 17. It'll focus on planets, asteroids, and comets. Mercury is the closest planet to the Sun. It is very dry with no atmosphere. The temperatures range from negative 170 degrees Celsius to 430 degrees Celsius, and this is mainly due to its slow rotation. So one side of the planet spends a long time facing the Sun, and the other side spends a long time facing away from the Sun in the shadow. In 1974, Space Probe Mariner 10 confirmed a heavily cratered surface, which is indicative of a very little to no atmosphere. Atmosphere for the Earth will burn up meteors, preventing them from striking the surface of the Earth. If there's no atmosphere, there's nothing to slow or burn the meteors, so all of them hit the surface of the planet, creating lots of craters. Venus is similar to Earth in terms of size, density, and mass. It has the hottest average temperatures of the solar system, ranging from 436 degrees Celsius, which is 864 degrees Fahrenheit, due to the runaway greenhouse effect. This is caused by high levels of carbon dioxide and sulfuric acid clouds. The thick atmosphere also creates higher levels of air pressure. So a lot of times, scientists will look at Venus to see what potentially could happen to the Earth if our carbon dioxide levels continue to increase. Retrograde, that means backwards. So retrograde motion means it spins on its axis backwards. It actually spins clockwise. The Earth is the only known planet to have oceans and life. There are some moons that have oceans, and there is evidence that water once was on Mars, but it's the only planet known to have a current ocean and life on the planet. It has moderate temperatures, atmosphere containing of oxygen, Earth's magnetic field, which is caused by the iron core. The Earth's magnetic field blocks the sun's electrically charged particles. These electrically charged particles are called solar wind, and these charged particles can excite atoms in the Earth's atmosphere and produce the aurora borealis, which is the northern lights, and aurora australis, which is the southern lights, by channeling these charged particles to the north and the south pole. Other planets have also been noted to have northern and southern lights, such as Jupiter and Saturn. Mars is a hot topic lately because NASA is planning to send people to Mars. That's its current mission. Mars's rotation is similar to the Earth's. Mars is 24 hours and 37 minutes, whereas Earth is 23 hours and 56 minutes. It also has very similar air pressure. Mars is smaller than the Earth, and it does not have liquid water on the surface. There is evidence that suggests that Mars at one point had water, but there's no current water on the surface as far as we know. Mars has seasons because Mars's axis is tilted. Remember, the whole reason why the Earth has seasons is because the Earth's axis is tilted. So any planet who has a tilted axis is going to have seasons. The surface of Mars is reddish because it has a lot of iron in it. It also has a lot of volcanoes, valleys, polar ice caps, craters, and river channels. Remember, the river channels are dry. There's no currently running water on Mars, but that is evidence that there used to be water on Mars. It has a thin carbon dioxide atmosphere. We've had two space probes, the Viking space probes, have landed on the moon, along with Curiosity, Spirit, and Opportunity, which are robotic cars or vehicles that can roam Mars. The rover spent about 15 years on the planet, which was a really long time. But unfortunately, it got stuck in a raging dust storm that blocked its solar panels, and essentially it slowly ran out of power. And it was declared dead in February 2019, I believe. Spirit and Opportunity, you can think of them as twins. They're pretty much identical, and they both landed in 2004. Spirit concluded in 2010, and Curiosity ended in 2018 due to a dust storm. The missions conclude that Mars is cratered and covered with loose rocks, Winds can get up to about 100 kilometers per hour, about 62 miles per hour, that create these dust storms. Mars is home to the largest volcano, Olympus Mons, which is a shield volcano. If you remember, a shield volcano is very flat. The reason why it is so large is because Mars does not have plate tectonics like Earth does. So the plate sits on top of this volcano and it continues to build and build, and it never moves off this, we'll say, hot spot. Mars has a large rift, Valles Marineris. Remember, a rift is essentially a valley from, let's say, plates being pulled apart. It is about 4,000 kilometers long. That's about 2,500 miles long, which would be about the width of the United States. And it can reach up to depths of about 7 kilometers or 4 miles deep. That's like 4 Grand Canyons. That's amazing. Our next topic is asteroids. An asteroid is a large chunk of rock or metal that orbits the sun. Most are located in the asteroid belt, which, if you remember, is between Mars and Jupiter. And the asteroid belt is leftover debris from the formation of the solar system. Essentially, it's a failed planet. It's a planet that never collected to form. The dwarf planet Ceres resides in this asteroid belt. Remember, a dwarf planet has one of the 3 characteristics of a planet missing. So in order for a planet to be a planet, it first has to orbit the sun. It second has to have enough gravity to crush itself down into a sphere. And third, it has to have enough gravity to clear its path, meaning it has to have enough gravity to pull anything nearby into itself. Well, since Ceres is in the asteroid belt, it clearly didn't clear its neighborhood or its orbital path. Therefore, it is not a planet. Can anybody find the Death Star? The Death Star is a reference to Star Wars. That's the identifying mark that makes it look like the Death Star. A meteoroid is essentially a small asteroid. It's a piece of rock or metal that travels through space. Most are smaller than sand grains. A meteor is a small piece of rock or metal that enters the Earth's atmosphere. So it's a meteoroid that's inside the atmosphere. They burn as they fall through the atmosphere, and they produce a streak of light called a shooting star. So when you look up at night and you see a shooting star, it's not really a star. What you're looking at is a piece of rock or metal that is falling so fast that the friction heats it up and it starts to burn. A meteorite is a small piece of rock or metal that falls on the planet's or moon's surface. So these are all 3 names for basically the same thing. The only difference is where they're located. Okay, so asteroids are in the asteroid belt, which is in outer space. So asteroids and meteoroids are both in outer space. A meteorite, the root word "ite" means mineral or fossil, and you're going to find minerals and fossils on the surface of the Earth. Think of halite, that's a mineral. Graphite, that's a mineral. Trilobite is a fossil. So anything with an "ite", you can think of it being on the surface of the Earth, and an "oid" will be in outer space. And a meteor, which is in between the "oid" and the "ite", is in between. It's in the atmosphere. It's not in outer space. It's not on the surface. It's in the atmosphere. A meteor shower occurs when the Earth passes through debris, and many meteors enter the atmosphere, causing a meteor shower. Some of the debris fields can be pieces of comets as well, instead of just meteors. Now, we tend to have meteors every night. We often can't see them because of the light pollution, but we do get meteors every night. So a meteor shower is just more of them, or they're going to be more frequent. About 30,000 meteorites have been found on the Earth. Most land in the ocean, because 70% of the Earth's surface is ocean. And most are going to be very small. The best places to look are actually in Antarctica, because they're easy to spot on the white snow. So this is an asteroid impact that formed in Arizona. It's pretty neat if you ever get to go visit this. Just to give you a scale, this is a road coming in, and this is a big parking lot with like a visitor center. As big as this comes nowhere near the size of the impact crater that killed the dinosaurs. The impact crater that killed the dinosaurs is in the Yucatan Peninsula, and half of that, or even actually more than half of that's in the Gulf of Mexico. Jupiter is the largest planet. Earth's diameter is about 13,000 kilometers, and Jupiter's diameter is 143,000 kilometers. However, Jupiter's density is 1/4 of the Earth. This is because Jupiter is mostly made of gas. It's mostly gas, but it does have a small rocky core. The gas that it has is mostly hydrogen and helium. Voyager 1 in 1979 discovered Jupiter's rings. One neat probe is the Galileo satellite. It was launched in 1989, and it took 5 years to reach Jupiter. It remained around Jupiter and orbited Jupiter for about 9 years. And near the end of its life, it was running out of fuel. So instead of just letting it die and continue to orbit, they decided to have it crash through Jupiter to collect as much data as it could as it fell through the atmosphere. This was in 2003 when it went through the atmosphere. Jupiter is very well known for the Great Red Spot. It's a giant hurricane, like a cyclone. It is 16,000 kilometers wide, or 10,000 miles wide. This is larger than the Earth. You could fit at least 2 or almost 3 Earths inside the Great Red Spot. So 2 to 3 Earths can fit right there. That's how massive this planet is compared to the Earth. Saturn is the second largest with a diameter of 121,000 kilometers. It's gaseous with mostly hydrogen and helium, very similar to Jupiter. It has 3 main rings with thousands of smaller rings inside. These rings are made up of tiny rocks that orbit the planet. The Cassini probe studied Saturn's rings in 2004. And another really neat thing is at the North Pole, it has a hexagon shape. How cool is that? One possible explanation for this is the different speeds, but a full explanation is not quite known yet. Another uncommonly known fact is the outer planets. All of the outer planets have their own ring system. It's just that Saturn has the most obvious one and the most visible one. So the rings are often left out of the other Jovian planets. But Jupiter, Uranus, and Neptune also have rings. Uranus is the third largest, 51,000 kilometers in diameter. It's the first planet to be discovered by a telescope. Voyager 2 discovered new moons, mostly made up of hydrogen and helium, but it has clouds of methane. The methane is what gives it its bluish color. One interesting thing with Uranus is its axis is horizontal. Essentially, it's on its side due to a collision. It spins fast and has a strong magnetic field, and it also has a faint ring system. Neptune is similar to Uranus in size. It also has a faint ring system around its equator. Neptune's year is equal to 165 Earth years. So every 165 years on Earth, Neptune has 1 year. Voyager 2 shows that Neptune has a similar spot like Jupiter. This is called the Great Dark Spot. Aren't they so creative in their naming? Neptune also has clouds of frozen methane, which helps give it its bluish color. Lower atmosphere is mostly made up of hydrogen and helium. And another neat thing with Neptune is the winds can reach 1,500 kilometers per hour. Okay, dwarf planets. Remember, a planet must orbit the sun, have enough gravity to crush itself down into a sphere, and have enough gravity to clear its path. Meaning, as it moves around in its orbit, it's going to pull in any object that's close to it. These dwarf planets were not able to clear their path. That's why they're not considered a full planet. Pluto has an irregular orbit that overlaps Neptune, so sometimes it's closer to the sun than Neptune is. It has a frozen surface of methane, nitrogen, and carbon dioxide. New Horizons was launched in 2006 and flew by in 2015 to collect really detailed images of Pluto. Ceres is located in the asteroid belt, and Eris is located beyond the Kuiper belt. Here's a diagram of our solar system. So we have Jupiter, Saturn, Uranus, and Neptune, and just beyond Neptune is the Kuiper belt. Notice Pluto, its orbit's a bit different than the rest, and it's mostly in the Kuiper belt, but this diagram doesn't show it, but it does cut in, and it's a little closer to the sun than Neptune is at certain times of its year. A comet is a lump of ice, frozen gas, and dust that orbits the sun and have very long elliptical orbits. Comets have three parts: the nucleus, or the core, which is a dirty ice ball made up of frozen gas, frozen water, and dust. The comet is the cloud of gas that surrounds it. So in the middle again is the nucleus. Around here is the coma. And the tail stretches out from the coma, created by a stream of particles from the sun. So the sun would be in this direction, and the sun's radiation is going to come, strike the nucleus, and blast part of it away from the sun. As a comet approaches the sun, it begins to warm up, and some of the ice melts. Gas and dust are released from the nucleus and spread out to form the coma. Then the tail forms and can stretch for millions of kilometers. Comets tend to originate in the Oort cloud, named after an astronomer, Jan Oort. So this is a diagram to show you how the tail changes as a comet approaches the sun. When the comet's far away from the sun, there is no tail, so it's just a nucleus. As that comet gets closer, notice the tail is always pointed away from the sun. That's because the sun is what's blasting or creating the tail in the first place. Animation is going to show you how a comet forms the tail as it goes around the sun. A couple of things you should notice. The comet's orbit is more elliptical or more eccentric than a planet's. A planet's orbit is technically elliptical, but it is, according to the naked eye, it looks really close to being circular. You should also notice Kepler's second law. As the comet gets closer to the sun, you're going to see it speed up. As it moves farther away from the sun, you're going to see it slow down. Okay, here you see the tail growing. Notice if you draw a line from the sun to the comet, you'll create the tail. Notice how the tail rotates around. But again, if you draw a line from the sun to the comet, you'll form the tail beyond that line. Notice the comet is slowing down because now it's getting farther away from the sun. So Kepler's second law, the closer a body is to the sun, the faster it's going to move. So it's going to move fastest at its perihelion and slowest at its aphelion, which is over here farthest away from the sun. We can also take a look at Kepler's third law. The farther away a body is from the sun, the slower it moves, therefore the longer the period, or the longer the year. So Mercury you see is moving the fastest because it's the closest to the sun. Venus is a little slower, Earth is a little slower, so on and so forth. The farther away a planet is from the sun, the longer the year. I'm going to speed up our comet a little bit. We'll watch it go around one more time. Pay attention to the direction that the tail goes. And here it starts to burn. It gets the longest when it's closest to the sun, and it wraps around. And it slows down, and the tail slowly fizzles out.